I've got an HP41C here, and I've got the copper connector attached to a PCB inside this module case. I've got some blanking parts not there because I found it's a lot easier to align the module if you've got something in the slot above or below it. So for now I'm keeping those in there. And plugging the module in is really just, that's it, you just plug it in. And the alignment is handled by the parts of the case. So you can plug it in there, you can plug it in there, and there is a definite sort of grab as it goes over the end of the flexi inside. And I've inserted this and removed it, as you can see, quite a few times, and it seems pretty happy in terms of pin deformation. The feel is the same, and the pins, as long as you don't miss insert, and that's difficult if it's in the case with both halves of the case, as long as you don't miss insert, I think you're fine. And there's enough spring in the contacts to actually hold the shape of the pins. This has actually been way better than I thought it would be, having seen how soft the pins are. It is, I mean, it seems fine. It is definitely delicate though, so you do have to be careful when you're inserting. If there's any sort of resistance, you have to stop. If I put that back in and pull the top out again, it's no problem at all. If you haven't got either in there, then it becomes a bit harder. You have to make sure that you're running along the case there, and here you have to sort of bring it down a bit, and then you can get in there. And again, you can insert and remove. So it's looking pretty good mechanically, although I'm still not really happy with how robust these pins are. But as you can see, you can plug it in, remove it, and if I open this up, you can see that I've got a PCB and I've got a ground connection there, so I'm going to wire the scope up to, well, I'll plug it in first. Plug it in, wire the scope up. Actually that didn't go in very well, but yeah, it's fine. It's not as easy to plug in with the case top off. Well, that's to be expected really. So if I plug that in there, I'll just put the camera on the scope and have a look at some signals. Okay, so we're on the scope, and fortunately there's some legends on here so I can actually see what the signals are. So if I turn this 41C on, I don't know if you can hear that, but it actually beeps every time I press a key, not really sure why. So we got clock 1, there's clock 1, clock 2, sync, ISA, data, FI, there's just a bit of noise there, no signal, PWO, and then you've got the B3, B4, they're actually 0 on this slot. VBAT I don't have anything on, and I'm not really sure why not. Maybe it doesn't actually come out to the slots I thought it did. And that's V, which is battery voltage, and then ground, which is, well, it's going to be nothing. So that seems to work. I'm going to take it out and plug it in the other side. So let's carefully plug it in without, because there's no case top, it's definitely trickier. There we go. So this is the other side, and we've got clock, that's clock 1, ISA, sync, data, FI, PWO, B+, the missing battery, and then high on B4 and high on B3. Now clock 2 I left out because clock 2 looks like that, and I think that is actually the signal on the flexi, so I think there's something not quite right with this flexi in here. because clock 1 is fine, clock 2 is like that, and it's the same on both slots on this side, so I don't think that's anything to do with my connectors. So yeah, seems to work. It's connecting electrically to the signals. Take it out, put it back in the other side, and have a look at some signals. Clock 1, clock 2's fine, ISA, sync, data, FI, PWO, V+, V3, V4 and VBAT. Nothing on VBAT again. Oh, what's going on there? That's interesting. Ah, so VBAT does have something on it. If I move my... Okay, so there's something wrong with that pin, so that isn't actually making contact. Now, what is interesting about the VBAT pin, and it's the bottom pin here, is that I don't think I've soldered it. Oh, hang on. There it is. This bottom pin here, I don't think I've soldered that far enough that way. So it's actually hanging out of the connector block, and the connector block gives it a lot of support, and it's actually moving around a lot. The rest of them are quite firm in the connector block, so I'm going to go and resolder that but further in and see if that makes a difference to this signal, because the VBAT is definitely missing there. Okay, so I've resoldered that pin, and it was definitely, well, I'd say about a millimetre too far out of the connector block. I'll go through connector blocks in a minute. So if I go to VBAT now, I do get the VBAT signal. So I think there was a problem there. So we've got clock 1, clock 2, sync, ISA, FI, data, PWO, then we've got B3 and B4, VBAT, which is there, and V+. So that is working a lot better. I don't think there's a problem with the clock 2, because it's just on one side of the flexi and it's been fine on this side, so I don't think there's a problem. The flexi, sorry, the pins on that side, they look fine, they're all at the same distance out. I did notice that after I'd soldered it and taken it indoors, but the VBAT line anyway. Right, I'm going to switch the camera back and go through the connector block. This is the connector and PCB in the case, lower part of the case anyway. So if I take, well, maybe I won't, because I've actually blue tacked it in there to give me the correct height for the back of the PCB. If this isn't raised up and actually held level, then the connectors are at the wrong angle and it doesn't actually plug in correctly. So that's something that needs to be done in the real case, but that can be done with the 3D printed case, that's not a problem. I've got some connector blocks here, and they're 3D printed, and you can see there's slots on the front because the connector pin's wider on the front than the back. The back has got little tiny holes, and you can see all the way through that 3D printed one. So what you do is you poke the pins through from the front side, this side here, and the wider part of the pin sits in that slot, and you can see there's a little bit of wobble there, and it'd be nice to close that down. I think the reason for that is that these etched pins are slightly narrower than I expected. I think the etch has actually etched them in sort of on the edge and reduced the width of the pins. Now I had these blocks made up with different sizes of slots and holes at the back. You can see they're completely different. And it turns out that the smaller ones are way better than the bigger ones because there's less wobble in the pin. You can see the angle of wobble there, if that's the correct technical term, is quite a bit more than the smaller hole, and that feels a lot firmer as well. So that can be sorted out, and we could even have more length this way of the pin held inside the connector block. These blocks are modelled on the original. I've got an original. Probably got an original here somewhere. Yeah, so these connector blocks are modelled on this, which is the original injection moulded connector block. So I think they moulded this on top of the pins, and that's something that can't really do. So it's going to be 3D printed, but I tried to make it the same. I think I've actually made the little fingers that poke out of the front slightly short, so that needs sorting out. Yeah, so I think if I actually had this manufactured correctly, this pin on the end, the V-back pin, just can't get the staff these days, I don't know who made this, I think that would have worked. So this is looking pretty good actually, these copper pins. The only problem is they're not particularly robust, definitely not as robust as these. You can try and bend these are solid. Really no, I mean, yeah, much more robust than these copper ones. But the copper ones, I've had that in and out of this 41C many times. I'm probably approaching around about 100 times. Let's do a few more while we're here. And it just seems to work. So I mean, you can do this and it's just fine. The other side, it's much better if you've got the blanking plates or another module in there, because the alignment is quite important for this. With the original, I think it would just jam. I can actually take that out of there. Well, if I've got another case, I can, yeah, here's another case. I can put this module in here. I think it's the other way around actually. Is it that? No, it is this way around. I can put this module inside this case and you end up with a long, I think it's a memory module this. I'll put that in that case. So that's now the original, and you can put that in there. And there's definitely more push needed to get it in there, and that's due to the stiffer material in the pins. But there's still there's still force needed, but it's a much softer sort of thing. But yeah, I think these copper pins, you could probably just about use them if you had to. I mean, I've moved the module in and out quite a few times now. I don't know how many times it would be going in and out, but that seems to be something it can put up with. The other question is the wear on the flexi, but if it does eventually wear out, it's not a total disaster, because you can get those at the moment. That is something that can be manufactured with modern suppliers. Yeah, that's definitely harder to get in and out. I don't think it's the fingers on the side, although they are more pronounced there as well. They actually poke out more. I don't think it's that. I think it's probably the pins, but yeah, I think it's definitely the pins because I've done it on a connector block. Let's try it on a connector block. Definitely done it. Yeah, so that's pretty. So that's fairly soft. That's a bit harder. Yeah, I'd say it's sort of twice as hard to push the original ones on as the copper ones. Anyway, got some more materials coming, so we'll try some other pins made out of different materials, which hopefully are going to be a bit more robust, something approaching the original.